right, welcome back to Online with an Architect, architectural decision number 2. We're going to talk about the vSAN storage policy going forward from our first decision about OSA versus ESA. So welcome back, James. Let's get into this important decision. So do you want to run us through the problem statements?
Yeah. Well, so we've chosen ESA, which wasn't a big surprise for Acme Corporation. And now we need to have a look at what are the implications of that decision. What are we going to need to decide now that we've chosen our overall storage architecture? So what are the storage policies going to be? What sort of failures to tolerate are we going to have to configure? And how is that going to impact our cost and efficiency, resiliency, and performance? Of course, that's all very important. Hopefully, we're making this decision before we have bought the hardware, because obviously, once you've purchased the hardware, most of your decisions are kind of made for you when it comes to vSAN. So
it becomes a constraint.
Yeah, very important to get in front of that purchasing decision when it comes to designing your vSAN architecture.
Yeah, absolutely. Fantastic tip there from James. And I think that's true for any IT solution. Design before you purchase.
Oh, absolutely true for any, but particularly important for vSAN.
Absolutely. All right. So let's talk about what the most appropriate storage policies are for Acme Corporation. So I think some of these are assumed in a lot of cases, but not necessarily designed for. So we're going to go through each of them because they are very important and there are implications to each of them. So simply the ability to self-heal is something that vSAN and other products market, and rightly so. But making sure that we have the underlying hardware and configuration that allows this to happen is very important. So measuring against these requirements is something we will do later in the justifications. So again,
and this is where we're going to be kind of balancing between our raw capacity that we're paying for. And well, in fact, we're doing that with most of these decisions, but that's kind of the balance where you've got your raw capacity, but then you've got your usable capacity based on the decisions that you make to meet your resiliency requirements that we're listing here.
Absolutely. So requirement 3 is an interesting one. And take from it what you will. It's a bit of a teaser. So we must be able to support a wide range of cluster sizes. So
why does Acme Corporation want to support a wide range of cluster sizes? Josh, did they tell you when they were coming up with these requirements?
Their system admin, when we did the stakeholder interviews, even the C-level executives are very keen on having a repeatable model.
The C-level executives were really interested in cluster sizes, were they?
Yeah, well, they just said they wanted something that was scalable and repeatable. They didn't want to have to pay very good people like yourself too often to do custom designs for every cluster. They wanted something they could repeat across all of their various sites around the world. So, yeah, making sure that it can start small and scale, I think, is the translation of that one.
There you go. All right. We talked about 24/7 in the previous decision. Presumably, Acme, like every other company, have an important online presence that they want to keep running all the time. So effectively, now obviously this is not true for every single device or piece of software in their environment. But when you're talking about vSAN, that is running your online presence. So therefore, vSAN's got to be up 24/7. We don't have a vSAN change window.
Absolutely. So very, very important. Again, performance has to be consistent for those online applications, and the environment must be able to scale, ideally independently, compute memory and storage where possible. I guess this comes back to your previous point in the last episode, James, just attach some shared storage to a cluster.
Yeah, if you need some shared storage, buy some shared storage and hook it up.
Yeah, so definitely we want to give customers as much flexibility as possible.
Yeah, but of course you've got vSAN Max there. So if you decide that there's value in standardizing across every single piece of hardware equipment you use, and there are valid reasons to do that, like for support, for example, you don't want to have a custom piece of hardware for a custom piece of hardware for storage, a custom one for running your management cluster, another different one for running your workload cluster, because then you could run into a scenario where you need to replace some hardware, but you've only got the hardware for your storage nodes, and it's actually your management hardware that has the problem. So, there's a balance there again, like with everything.
And just repurposing. You might have a cluster that's got 16 nodes in it, and now it only needs 8. You want to be able to move those 8 into something else. So
that's right.
Standardization is very valuable. The larger the organization, the more this makes sense, because the pros outweigh the cons of potential inefficiency in a cluster and stuff like that.
Yeah.
So again, constraints. We talked about dedupe on the last decision. Not really a big constraint in reality, but it isn't supported as of yet with ESA. So we need to consider that from a capacity perspective. And this one is quite a typical constraint that I've certainly experienced, and quite frustratingly on many occasions, which is it's difficult to get into secure data centers to actually do physical work sometimes, especially if it's a vendor coming in to replace hardware, right? They haven't been to the data center before. They might need to be inducted. They might need to be escorted, things like this. So, assuming that you have access to the physical hardware in a timely manner is probably a pretty big risk. So in this case, there is a colo. Anyone who has to go in has to be inducted, quite normal in IT, but something that isn't always considered from a resiliency perspective.
Yeah.
All right, similar risks to our original decision. So we're trying to prevent or we're trying to understand that single device failures can occur, as well as dual concurrent failures, and also subsequent failures, meaning we've suffered a drive failure, and then a short space of time later, a subsequent failure has occurred. A rebuild may or may not have had a chance to complete in that time.
So the one that I'm interested in there is risk number 7, single storage device failure of, well, it's not going to be a HDD, but one of your drives during planned maintenance, or if you're doing an upgrade, or if you're doing patching. This is one that I think is often not considered. And again, maybe it is considered, but it results in more cost. But with a 24/7 operation, you really want to be careful that if you're doing planned maintenance, you're still protected. You still have redundancy, because you're going to be doing maintenance when the vSAN infrastructure is being used for its business purpose.
Absolutely. It's going to be in production 24/7.
Yeah.
So no change windows, no maintenance windows, etc. All right. So assumptions, a target workload. It's a couple of thousand VMs, 4,000 vCPUs, 12 terabytes of RAM, and 320 terabytes of storage. So it's not a massive environment, but the criticality of the workload is very high. So even if you have a small cluster or a small number of workloads, it still may be very, very critical. So there's plenty of customers who have way more VMs and higher requirements than this, but this is just for example. So our options, James, what could we do in this scenario?
Well, you can see them there. There's a bunch of different options. Mirroring, multiple failures to tolerate, whether it's mirroring or erasure coding. But what are the advantages, for example, of using mirroring versus erasure coding? I mean, I guess you are traditionally going to get better performance with mirroring compared to RAID 5 in a traditional RAID 5 versus mirroring scenario. But that is not necessarily the case here.
Yeah, it's certainly not. So ESA, they've spent a lot of time and effort optimizing the performance on the log structured file system, and this has led to a lot of efficiencies where VMware have come out and shown data that RAID 5 very similar to FTT1 mirroring. So if you're getting very similar performance, then and you're getting more capacity, then it may well be advantageous to go with the erasure coding RAID 5 or RAID 6 option.
So then our decision is?
Boom. Again, no big surprise here, I would say. But the thing I like about these decisions is, even though they are obvious, it's not always like when someone says, it's obvious you're going to do this. And then you say, well, why is it obvious? And they say, because it's best practice. Well, we don't want people to say that. We want people to understand actually in depth why they've made a decision, And there's always going to be an implication to a decision. And it's always important to understand it, even if it's considered simple or obvious. It might not be obvious to someone else. Someone might have never used vSAN. They might never have used VMware. So as an architect, we need to assume a fairly low common denominator, and it's good to document them anyway. If it's so obvious, it doesn't take very long.
Yeah, exactly right.
All right, so we're using RAID 5. Great. Why, James? Tell me why.
Well, because it has enhanced durability during maintenance mode when using erasure coding, and that ensures write operations maintain data redundancy during maintenance mode. This is what we mentioned before, the 24/7 requirement of having vSAN running even during maintenance mode. We're taking that into account using RAID 5. And then the point which you alluded to before, the log structured file system is vastly improved for 5.6, and it has the performance leg to temporary write mirrored data before, my headset's talking to me again, before a full write stripe performance to the capacity leg, and thus thus eliminating the overheads from the critical write path.
Yes, that is literally a copy paste from VMware's website for those. And I copy pasted it because it's spot on. It sums it up beautifully. So, you've got the performance leg, and then you've got the capacity leg in the storage pool of ESA. So this is why you can get such good performance, because the writes are happening quickly into that performance leg across all the drives, and then it's actually going down to the capacity leg again across all drives. So it's distributed operation. It's very efficient.
Yeah, so this is kind of like a win-win here. When you're choosing RAID 5, you're getting both extra capacity and performance, and you're not losing anything in terms of performance if you were comparing it to a mirror. So yeah, certainly seems like the way to go
during maintenance mode.
Oh yeah, sorry.
It really is. It's like win-win-win, tick, tick, tick. So yeah, great job to the engineering team again for that. So RAID 5 also benefits from a scale-out design, and a scale-out design is very much in line with what HCI is all about. You don't really want to have a 3-node large cluster. You would prefer to have 6 smaller nodes in most cases than 3 big nodes. So RAID 5 striping across those nodes is a benefit as well. So it's aligning with what we want here.
Sure. That is going to have some implications when it comes to cluster sizing, though.
Yeah, absolutely. So I think we might touch on those, just thinking about that. So we're getting maximum storage capacity really here. So our usable capacity is a 1.25 to 1 ratio of physical capacity. So that's quite a good ratio. So it really supports our first decision about the architecture choice, minimizing cost and maximizing usable capacity. So I think that's a really good one, because mirroring obviously is a 2 to 1 ratio. So effectively half the raw capacity is usable. That's really, really good. It also means that we can self-heal from failures. RAID 5, of course, is an N+1 level of resiliency, so we can protect against those single device or single node failures, which is great.
Yeah, that's pretty cool that it does that on its own, compared to traditional RAID groups and that sort of thing. It's really quite a fancy storage system.
Yeah, absolutely. It's fantastic, and that's certainly an advantage over traditional storage. And of course, justification 7 is just highlighting that we've got 4 separate risks which are mitigated with RAID 5, and those numbers are actually wrong. It should say RK001, but nonetheless, those risks are mitigated by this choice, which is very important to make sure we mitigate any known risks. And constraint number 2 was about access to data centers, which I highlighted earlier. Of course, if we can self-heal without having to replace the hardware, then the time it takes for us to get into the data center, or the availability of hardware to replace failed devices, is less important. It's not irrelevant, but it's certainly less important. So we can replace it next business day instead of having like a 4-hour, hardware a replacement warranty, which can save you cost. But in reality, I wrote a blog about this a few years ago, actually. In fact, a long time ago. If you're relying on a hardware support contract for 2 or 4 or 8 hour response as part of your resiliency plan, I would say that is a fairly bad decision, because in my experience, it's very rare that a vendor or vendors can actually replace hardware within those periods of time.
And so I think saying self-healing, it sounds really good, but what does it actually mean? So the point is that when you get a object or a drive failure, then without self-healing, you would be in a scenario where a second failure is going to take your storage offline. Self-healing, of course, corrects from that condition so that if you have a subsequent failure, you're still protected. Your storage is still going to be online. So that's the real life implication of having self-healing storage.
And a huge,
as opposed to a traditional, as opposed to a traditional storage array where if you're running RAID 5, you have a drive failure, you have to get somebody in there to replace that drive, because if another one fails, you're offline.
Absolutely. And the other thing that I've seen quite a lot, or maybe not quite a lot, I've seen quite a few times nonetheless, is where you've got like an 8-node cluster. You have a node or a device failure. So node 8 is degraded. It self-heals, and you've got 7 nodes which are working correctly. And then something else can go wrong. A network, gets pulled out or fails or something. It can self-heal from that as well. So it can actually tolerate rolling failures. Now, of course, you need to have sufficient time for the resynchronization to happen. But yeah, in these platforms like ESA, they can self-heal from multiple failures and very, very resilient, more so than a traditional SAN for sure. All right, moving on. Implications. So cluster sizes of 3 are actually supported with ESA for RAID 5, but it really wouldn't meet some of our requirements. So it's kind of, you can do things at the minimum, but realistically, you're not self-healing as well or completely. You can't tolerate subsequent failures. Maintenance becomes a problem.
You're doing maintenance, you're at risk.
Exactly. And we certainly don't want that anytime, but I don't think it's acceptable in a 24/7, 365 operation. So in this case, some of the benefits of RAID 5 really come in when you're using the 4+1 stripe size rather than 2+1. So really, we're talking about a cluster size of about 6 or above to get those benefits and to be able to tolerate node failures and continue with that efficiency.
Yeah, and that seems kind of excessive if you just look at that recommendation in isolation, saying you really need 6 nodes in your cluster. But if you go through, like we have here, all of the various settings and the implications of the various settings and configurations that lead to that, then you can see, it probably is best to have at least 6 nodes in our cluster.
Absolutely. And look, for a lot of customers in, say, the US, 6 nodes is tiny. Right? This is nowhere near a constraint. In some geographies, or even in Australia, we have a lot of customers who do 3 and 4 node clusters. So there's things to consider. But certainly if you've got any sort of scale, 6, 8, 12, 16 sort of nodes can be very, very efficient.
But for all of these reasons, you want to have 6 nodes. So therefore, you want to be in front of the hardware purchasing decision so that you can make sure that when you're buying these nodes, you're better off if it's going to be overkill, for example, if you're buying large 4-way servers, for example, if 6 nodes is going to be overkill, then you want to be there in that hardware purchasing decision room to make sure that you buy more smaller servers rather than fewer larger servers for these reasons that we're outlining.
Yeah, absolutely. It's incredibly important to make sure we design before we buy hardware. There's been so many times in my career I've been thoroughly frustrated because the customer had the budget to do things to a very high standard, but because the purchasing decision was done without the design phase being done, they ended up with a solution which, I was very frustrated because it felt like it was barely viable, whereas it could have been, really top of the tree type solution. So, very important. Get your architects involved early, for sure. And sorry to the salespeople, your purchase order might be slightly delayed, but your customer will be far more happy with the end result. So just trust your architects to look after you as well. So, of course, RAID 5 provides great capacity efficiency, logical to physical, which means we've got great cost efficiencies. Larger hosts, if we did go down that route of having 3 big hosts or 4 big hosts, the impact of a failure is also significantly higher. In a 4-node cluster, it's 25%, whereas in say, an 8-node cluster, it's 12.5%. So, if we just design a cluster as a scale out, the impact of a failure is lower. We can recover quicker and therefore tolerate subsequent failures. So there's lots of things to consider here. And I've been telling people doing HCI this for about 10 years, and hopefully the message gets through because it's a huge value to do things properly.
Yeah. Now, the 5th implication there is quite an interesting one. And this is talking about we're not getting N+2 with RAID 5. But we're arguing here that that's not really a problem. Do you want to elaborate a bit more on that, Josh?
I do. I like this one. So RAID 5 is definitely not N+2. So let's be very clear. It's not N+2.
And that was one of the requirements.
It was N+1. So RAID 5 is N+1. Now, in this environment, we've highlighted that ESA and other HCI products, in fact, allow you to self-heal. So if you have a failure and you self-heal, you can tolerate another one, which some people would argue is kind of close to N+2. It's not really, but it's closer to N+2 than it is N+1. It's in the middle.
Approaching N+2.
Yeah.
You could say, I think.
Exactly. So we're approaching a level of resiliency, which is N+2, while only having N+1. So technically, if we have maintenance and we have a host in maintenance mode, so one of our objects is offline, the enhanced resiliency of, or enhanced durability, of RAID 5 is writing another object somewhere else. So then we are actually kind of back to, N+1 for those new writes, right? And then we could potentially tolerate that failure even during maintenance, despite not really being at N+2. So it's a bit of a gray area, but it's a pretty good trade-off that we're getting enhanced durability during maintenance.
I agree.
While still only having the overhead of N+1. So RAID 5 is pretty damn good is what we're getting at here.
I think you're only going to go for that N+2 in your extremely, extremely critical scenarios. Like maybe you've got, I don't know, a database or something that just absolutely 100% has to be up all of the time and is a real problem to restore if there's ever any data corruption issues or something like that. Because for just about everything else, you're covered with N+1 plus self-healing.
Absolutely. So N+1 plus the self-healing is very, very good. And certainly in my experience, more than 10 years doing HCI, very, very rarely do you have downtime in that scenario in a properly designed environment. And for the cases I've seen, it had nothing to do with the software layer. It was simply just bad luck. It was a bad batch of drives or bad batch of servers or, networking issues. It wasn't really anything to do with the software-defined storage. So you're very resilient.
And of course, we're assuming here that you've got to maintain a bit of additional storage such that this self-healing can occur. But
Absolutely. I think we might touch on that later, just quietly. So absolutely. So lots of good things there. So the implication here is we've actually kind of covered it off, which is the N+2 level failure scenarios we're not strictly adhering to. If we needed to strictly adhere to N+2, then RAID 6 would be required. And of course, the implication there is the minimum cluster size is 5, but realistically, if we want to have the 4+2 stripe to get the capacity efficiency and the most performant efficient stripe, we really need 7 or more nodes to make that happen. So, RAID 6 does have that implication of requiring more nodes, certainly to operate more efficiently, and also the usable capacity decreases from a 1.25 to 1 to 1.5 to 1. So
yeah, this is a scenario where we're choosing not to spend the extra money and not to enable the most protective solution because it introduces implications or constraints that are that we deem as not effective. No, that we deem as too constraining. Constraints that are too constraining.
Yeah, I just don't think there's not enough justification for it. But in saying that, if you're not capacity constrained and you're going to have a cluster size of, say, 7, 8, 10, 12, whatever, and enable it for sure. Like, it's still very performant. Yes, there's some capacity overhead. So if your application is not a performance consideration, then RAID 6 is fine. And if it is a performance-driven app, ESA is very high performance anyway. So in my experience, even in the early days of HCI, there weren't a lot of workloads that HCI couldn't actually service because it's far superior than just traditional SANs. So, even from a performance perspective, RAID 6 is great. So yeah, I wouldn't stress about performance too much. There's other things we can do to improve performance. It's not just a storage layer issue. And then the last implication is we need to consider day 2 operations. So surprise, surprise, that's our next decision, day 2 operations. So capacity management is critical. No surprise at all. So we need to consider things like the operations reserve and the host rebuild reserve.
Yeah.
All right. So related decisions. Obviously, our first decision, vSAN001 decision, OSA versus ESA was related. We've talked about, obviously, failures to tolerate in this episode. And in the next episode, we're going to talk about operations reserve, host rebuild reserve, maintenance mode options. And in a subsequent episode, we'll talk about vSAN ready nodes and more.